Hello there and welcome to this video. Now, a few days ago, Mr. Thrive and Survive put up a video in which he claimed he was debunking a video that I made in which I use information that I found online to calculate estimates for the length of the Tropic of Cancer, the Equator and the Tropic of Capricorn. Now, Mr. Thrive and Survive has made a video, like I said, trying to explain why I'm wrong. I've watched his video a few times, and to be honest, I'm not quite sure what his point is. But to be fair to him, he was very polite and respectful towards myself in the video that I made. So I want to keep this polite at least. But I do want to go through what he said, and not so much explain why he's wrong, but just talk about how he didn't really address what I said in the video. Anyway, this is something he says quite early on.
And this, that, and the other, it is a pretty good shot at it. But there are some things that he just simply doesn't know.
So he's basically opening by saying that I've made a good video, that my reasoning's sound, but there are things that I don't know. So I presume that at some point in this video he's going to tell me something that I don't know that shows why my video was wrong. Now, he's made an almost 30-minute video about this, so I'm not going to play all of it. Obviously, I've selected some bits and pieces to have a look at. We'll start about here for maybe 30 seconds.
Estimate. But he comes out with good numbers. It's a good rough estimate. No problems there. Tropic of Capricorn, same thing, 23,040 miles. When he measures it at the equator, he gets 25,200. Now this is, I believe, a larger number than what science says, but it's pretty close. So in any case, this is what he does, and as you can see here, he double checks it and everything, but everything is fine. And he makes the point then that the Earth has to be a globe because this works out right. Okay.
So he goes through the summary of my results, in which I found that the two tropics were about the same length, roughly. If you go back to here, I found that they were roughly 23,000 miles each, and the equator is roughly 25 miles long. So the two tropics are about the same length, and the equator is longer, which supports the spherical Earth model and completely doesn't support the flat Earth model. He seems to agree with what I've done here, but as he said at the beginning, there's something I don't know. So let's go forward a bit and see if he can get to what it is that I apparently don't know. So he talks again a little bit more here about what I did, and also the website I used, SunCalc.
Okay, here we go. And here's where somebody should pick up there's a problem. We picked this up, didn't we? This is one of the problems with the globe right here. I'm going to move this back and forth as he did. He's showing what he's doing is he's measuring from one coast to the next, from sunrise to sunset, just like that.
It's not quite what I did. What I did was, from SunCalc, I got what time solar noon was at two different locations. So I was using just this figure here, solar noon. So I got the solar noon, what time solar noon is in GMT on the east coast of Mexico, where the Tropic of Capricorn, Tropic of Cancer is. And then I got what time solar noon was on the west coast of Mexico, where the Tropic of Cancer is, which tells you how long it takes for the sun to cross Mexico along the Tropic of Cancer.
Now, at this point, where that marker is, the X, right over the eastern part of Mexico right now, that is where the observer is. Now let me move it to the middle of Mexico so you can see all of this here. This is what's very important. During the day, what's going to happen here? Remember, and all along right here, the sun is overhead. We're still on a ball. It's very still close to the same size as it was then at the equator. Look at the path of the sun. Look at the path of the sun. It is not directly overhead. Only at noon is it directly overhead. And when somebody sent this link, it really dawned on me. It's like, why didn't anybody figure this out before? And
Okay, so the point he's making seems to be that because the tropical Cancer is running east to west, and yet the sun seems to be following this path like this, and it's not rising from the east, even though it's following a line from east to west. It's rising kind of almost northeast. Well, the first point is it's got nothing to do with the calculation I did. Absolutely nothing at all. But also it shows that he doesn't really understand the geometry of a sphere, and I'll explain how this works later on. Now, let's listen a little bit more to what he says.
Haven't noticed, and we can cover this in another video if people want to see it. The sun will and the moon will go across the sky. They appear straight the whole way until they get very close to sunset. Then they do a hook right at the end. There's a hook at sunrise, and there's a hook at sunset. It's a bending away from the east at sunrise and towards the east, towards the west at sunset. It moves slightly to the south after sunrise, and then moves straight across, and then at sunset you get this hook again. And if you look at these time-lapse videos, we see that. That should never happen on a globe. You should see.
It's exactly what should happen on a globe, and I'm going to show that, as I said, later on. Now let's look at something else, because he goes on about this for quite a long time. Let's go to about here. The next thing he does is he brings up 3 flat earth maps at 3 different times of year, with presumably showing where the sun is lighting up the earth at those 3 times a year.
Let me put a disclaimer in here that I'm not saying this is the perfect flat earth map, but this is going to go to his point, why he says that our map cannot possibly be correct.
No, it's not. Now, just a point about here, about this. How could the sun possibly form these shapes of visibility on the flat earth? This one here above on June's kind of feasible. It's forming a circle. So you can imagine the sun being at the centre of this circle. Except the circle in June would pass right through the North Pole, but I won't worry about that. Now, you go to the equinox, where it forms a semicircle, which is just...
I want you to notice...
which is just... How could the sun form a visibility shape like this? And then when you go to December, it just becomes utterly ridiculous. How could the sun be visible like this, but not visible here? Doesn't make any sense.
That we have the light accounted for correctly, don't we? And this is on a different map, which we're going to look at in another video. How does the sun hit the earth on the equator on the equinox dates? No curve at all. But here, isn't this how the curve looks on the other 2? You know, you either got this curve right here, or you have this curve right here. And we saw that. So, at least on our model, the lighting is correct, isn't it?
Not really. Anyway, what he does next is... Well, I'll just let you see. Alright, so he's taken a screenshot from Sun Calc and superimposed it on top of this diagram. Now, this diagram on Sun Calc has got nothing. It's not about the sun's visibility range. It's just... anyway. Now, this one here about June, I suppose he's sort of making some kind of point here that it looks like the sun's following a kind of circle, although when you look at that shape, it's not really a circle. But this one here, the way he's placed it, he's placed where the sun is directly overhead at the North Pole. I mean, the equator, it's directly overhead above the equator, which is about down here. So what he's done here is just completely meaningless. Now this is even worse because this is December, but he's superimposed the June solstice from Sun Calc on top of here and placed the sun again somewhere near the North Pole when it would be right down. In December the sun's above the Tropic of Capricorn, which passes through Australia and goes round like this. So why would the sun... these diagrams just don't mean anything. They don't show anything. It's just... I don't mean to be rude about this, but this just doesn't mean anything.
There's no way that you can come up with it correctly. This is why there's all kind of curved lines that I was trying to show on dateandtime.com that people just can't get. And they swear, oh, it's a straight line. Really? No
one says it's a straight line. Anyway, let's move on. It kind of goes on about this for a while. Oh yeah, let's go to about here.
So here's his exact point why he is saying the flat earth is not correct. Because when the sun is on the inner ring here, the yellow ring, it is traveling over a much less distance. This is the flat earth model here. That is the summer solstice. And then it moves down to the equator, which is the orange line. And as you can see, it's a larger circle, so it's got to travel faster as it heads further south. Then when it gets even farther south, still on the, that's the equivalent of the Tropic of Capricorn, the winter solstice in the northern hemisphere. So his point is that, the sun was traveling at the same speed all 3 times of the year.
No, it's not. I wasn't saying that. I was saying the opposite. I'm saying that the sun is travelling faster when it's directly above the equator and travelling slower when it's directly above the tropics.
And that's what makes flat earth impossible.
No, that's not what I'm saying. The reason flat earth is impossible is because if you do the calculation, you find that the Tropic of Cancer is the same length as the Tropic of Capricorn.
We know actually that the sun does not travel the same speed all year, which is a proof that the globe is not right.
No, it's not, because you would expect that on both the globe and the flat earth model, that the sun wouldn't be travelling at the same speed across the surface of the earth at different times of the year.
What science wants to say as an excuse is, well, there's a 3% difference. You see?
What?
We don't have an exact circle, perfect circle. We have a slightly elliptical orbit around the sun.
He now goes into discussing the fact that the Earth forms an ellipse around the sun, which has absolutely nothing to do with my original video, and it's not even got anything to do with what he was just talking about. It's nothing to do with that. The reason the sun moves between the tropics, and the reason it's moving at different speeds across the Earth at different times of the year, is because of the tilt of the Earth's axis. The axis that the Earth is turning on sometimes points the north towards the sun, and sometimes points the southern hemisphere towards the sun, and two times a year the sun is directly over the equator, on the equinoxes. This has got nothing to do with it.
And we're slightly closer to the sun in winter, actually, in the northern hemisphere, and farther from the sun in the summer. And
It's got nothing to do with anything.
the globe Earth. This is the infamous to the globe Earth people, analemma.
Again, the analemma, that would be a whole other discussion. It's got nothing to do with my video. It's got nothing to do with the rest of his video, and it's not a problem for the spherical Earth. Now that's what he talks about for the last 9 minutes or so of this video, is the analemma.
It is there, right there, March 20th, September 23rd. Okay. Also, the sun is moving fastest, okay, from one day to the next, right here, right there, and on the other side. See how much space there is between the two? A lot of space between the two. Like, I don't know, 2.5 or...
Well, the rest of the video, all he does is just demonstrate his misconceptions about this, but now if I go back to what he said at the start,
pretty good shot at it, but there are some things that he just simply doesn't know.
what are the things that I simply don't know? There's nothing in this video that explains why my video is wrong. The only thing that you really seem to bring up is the fact that, or what he brings up is the fact that the sun rises north east and sets northwest, and he thinks that because, not there actually, when it's above Mexico, yeah, here, it looks like this, which he's confused about. Now I can explain that, it's pretty easy. It's really just to do with the, now I've got a sun card myself. Now you can see I'm on the June solstice here, so the sun is moving across the Earth like this. Now if you're on the Tropic of Cancer, which is here, you'll see the sun coming from almost northeast, go directly overhead and then go west, but the sun will follow this path like this. Now he seems confused about the fact that the sun's following the straight path from east to west, and yet you see it like this. Well, it's really just to do with the geometry of a sphere and what we mean by east and west. Now, when we say going due east or due west, what we mean is following a line of latitude, which are these lines here. Now, these lines of latitude on the Earth, they don't follow paths of least distance between two locations. Okay, now if I can use this. This will always give you the path of least distance between two locations. So if I choose a point there and a point there, this is the path of least distance, which is what we mean by a straight line on the surface of the Earth, even though it curves into the third dimension. But within the surface of the Earth, it's a straight line, because it's the path of least distance. And like I was saying, these lines here going across the way, these lines of latitude do not form paths of least distance, except for one line, the equator. And the reason for that is because the equator cuts the Earth in half. It cuts it into two hemispheres. So that will follow a path of least distance between any 2 points. And then we can demonstrate that. So if I go to here, you can see that the path of least distance, or as the crow flies as we call it, is follows the equator. Right, now, let's see what happens on the Tropic of Cancer. So if I go to this line here, the prime meridian, and I'll start here. So suppose you're at this point here. Now you see the sun, if you're on the Tropic of Cancer on the June solstice, you see the sun for about 13.5 hours a day. So you start seeing it when it's about 6 3/4 hours east of your location, which is about 100 degrees. So if I go to 100 degrees east on the Tropic of Cancer, where is it? It's about here somewhere. Yeah, it's about there roughly. Right. Let's see what happens. Now look at that line there. This line here is the path of least distance between where you are and where you start to see the sun. You start seeing the sun when it's here, if you're over here. Now let's zoom in on this location. Okay, so you can see the Tropic of Cancer is going east to west. So if you go due east, you'll eventually get to the point where the sun is directly overhead. Where the sun is directly overhead when you're just starting to see it. But the direction it is actually at from your location is about northeast, which is exactly what you see here. So if I put it roughly where I am on Google Earth, you can see you get the same shape. Okay? It's just to do with the geometry of a sphere, that's all it is. And you can see for yourself that those two lines rejoin over here. So the sun is always travelling along a line that's going east-west, but it's not following a straight line over the surface of the Earth, it's following a curved line. It's not following a path of least distance. Okay, a straight line between where you are and where the sun is directly overhead goes like this. Now similarly, if you're in the southern hemisphere, let's go there. Let's go to 100 degrees east. Just about there roughly. And it's the same thing, except the line now goes to the south. So if you're at this point here, well, it'd be in the middle of the ocean, but never mind. So if you're at this point here on the Tropic of Capricorn, on the December solstice, you would see the sun coming from almost southeast. If we go to the December solstice here, oops, which is about there. There we go. It's about the same place I'm at on Google Earth, and you get the same thing. You get the sun coming from the southeast, going directly overhead, and then going southwest. Okay. So again, the sun is always following a path from east to west, but the direction that you start seeing it at is southeast. And then it would go to the southwest and set that way. So if you did the same thing going for the end of the day, you would see it going southwest. Now if you're on the equinox, and you're on the equator, and like I said, the equator follows paths of least distance because it cuts the Earth right in two. So you can see that the line now follows the equator, the path of least distance. And that's why you'll see the sun coming from the east. And this will work anywhere. So supposing we are about here. Now let's go to 100 degrees east on the equator. Sorry, no. On the equinox, it won't be 100 degrees, it'll be 90 degrees because you see the sun for 12 hours. So it'll be a quarter of the circle. So we go to there and we go back. You can see that this line, once it gets to here, is actually pointing east. So this is why any point on here, if you join it with the path of least distance to the place where the sun, where you would start seeing the sun, if you were on the prime meridian on an equinox, the sun would be directly overhead here, but you would always see it coming from the east. Okay, so there's absolutely no problem at all with the information on Sun Calc. It's completely consistent with the spherical Earth and completely inconsistent with a flat Earth. You couldn't even get anything remotely resembling this on a flat Earth, as I've pointed out in other videos. So all this information is consistent with the flat Earth. Sorry, no, it's consistent with the spherical Earth, inconsistent with the flat Earth. And there's nowhere in this debunking video that supposedly debunks my video in which it's actually explained why the calculation I did is wrong for calculating how long it takes for the sun to get along the Tropic of Cancer or Capricorn from one place to another using the solar noon. So the video didn't debunk me. It had a lot of misconceptions in it. It had a lot of things in it that didn't even make sense. And it had a lot of completely irrelevant information, but there was nothing that actually explained why I'm wrong. So that's really all there is to say about it.